Hello everyone, Aaron here. Welcome back to Leetcode, and today we are doing the smallest string with swaps problem. This problem is stated as you are given a string S and an array of pairs of indices in the string pairs, where pairs I equals AB indicates two indices 0 indexed of the string. So A and B are indices. You can swap the characters at any pair of indices in the given pairs any number of times. So we could go swap positions A and B, then we can swap positions A and B again and again and again. Let's just flip flops them back and forth. Return the lexicographically smallest string that S can be changed to after using the swaps. So here we can swap 0 to 3, so we can swap the B and the D. And we can swap 1 and 2, we can swap the A and the C. So obviously we would want to swap those, and we want to swap those. That makes sense. Then swapping 0, 3, 1, 2, 0, 2, so that we can swap the outsides and the insides as before, but we can also swap those two. So we'd want to swap B and D. Yeah. We'd want to swap A and C. No, we'd want to swap A and D, because that would get it further. I'm just realizing how complicated this problem is. So I had been thinking right until this moment that, oh, this is easy. We want to look at all the pairs we can swap and just find whichever one is least and make the swap if we need to. So for example, D and B, we want to put the B at the front. And then we want to swap the 0 and 2. Put the A and the B the other way around, which is a good swap. But how did we know to do that first? Why didn't we swap the A and the D first? Because that would be the obvious thing to do. If I can swap, oh hang on, if I can swap 0 and 2 and 1 and 2, then I can swap 1 and 0. And if I can swap 1 and 0, I can swap 0 and 3. Jeez, I can do any transform I like, basically. I can just sort them. So here I can sort them, and here I can't. Because I can't chain together moves. Hang on, so if I could... I'm having one of those headaches with pictures. Right. If I can swap 0, 3, 0, 2, and 1, 2, if I have 0, 1, 2, 3 as my indices, if I want to swap, say for example, 0 and 1, which by default I can't do, is it possible to do that with a series of these? So it would be using these two. If I swap 0 and 2, that gets me 2, 2, 1, 0, 3. Then I swap... No, I want to swap 0, 2, 1, 3. I want to swap the 1 and the 2. Then I want to swap 1, 2, 0, 3. I want to swap 0 and 2. And then I can swap 1 and 2 again. 1, 0, 2, 3. Okay. So if I can chain together swaps, I can reorder any elements arbitrarily, because I just sort of do the action and then make the actual swap and then undo the action. So that means if I can find the word I want to use is the transitive closure. And what a transitive closure is, effectively, it says you can get from 0 to 1, you can get from 1 to 2, then you can get from 0 to 2. Seems obvious enough. And sort of if you complete that whole set, that's called the transitive closure. That's kind of what I want. Here, for example, there is no closure. Well, this is the complete closure, effectively. You can get from 0 to 3 and you can get from 1 to 2, but those two aren't connected in any particular way. Whereas here, I can get from 0 to 0 to 2 and 2 to 1, so I can also get from 0 to 1, and I can get from 0 to 3. And because I can get from 1 to 0, I can get from 1 to 3, and because I can get from 0 to 2, I can get from 2 to 3. So on and so forth, like that. So these ones actually all end up being one huge connected chain. That's what I need to find, isn't it? It's not a transitive closure, it's a connected graph. So here we've kind of got two distinct sets. The indices 0 and 3 form a closed set, and the indices 1 and 2 form a closed set. But here, the indices 0, 1, 2, and 3 form a closed set. So that means I can take these and just put them in order. And here, I put the 0 and 3 in the order, and I put the 1 and 2 in the order. So this one here, 0, 1, and 2 form a closed set, so I just put them all in order. Okay. So what I actually want to do is find closed sets of the pairs, and then what I want to do is I want to do let subsequences find subsequences of S using the closed sets we've found. So for example, here we would go 0, so here we'd pull out 0 and 3, D and B, that would be one of the subsequences that we've got, and CA would be one of the subsequences. And then what I want to do is subsequences map subsequence. Right now, what we want to do is we just want to do a string sort, which is a little bit of a pain in JavaScript. And then finally, it's going to be recombine sorted subsequences equals subsequences.map. It's going to be the sorted subsequences with the closed sets. Okay. This doesn't feel too bad. This is a very high-level sketch. I'm sure actually implementing these would be a little more difficult. If I sound a bit gun-shy, it's because I don't know, as of solving this problem, whether I will have released the video I made for yesterday's problem, which basically kicked my ass. It drove me batty. So I don't know if I've released that video or not. But I'm a little bit gun-shy with this one because I found it so difficult yesterday. So this could be a horrible mistake. Anyway, let's write the function find closed sets pairs, pairs, number. We want to do that with number as well. Well, I kind of want sets, but whatever. How do I want to do this? basically 0 and 3 forms a set, 1 and 2 forms a set, but then as soon as I find 0 and 3 forms a set, 1 and 2 forms a set, and 0 and 2 it joins the set. For pairs for each pair, and then it's let left equals null. I'm going to do something quite naive to begin with. Basically, I'm going to go through all of the sets that we already have and find whether one of the pair elements, this pair, for example, here we've got 2 sets. When we get this one, we find the left is already in this set and the right is already in this set, so I want to join them together. So what I want to do is sets for each set if left, no I don't, actually I'm not even gonna, I really do want a set here, don't I? I'm not going to type that just because I don't know how to state it. If left does not equal, no sorry, if left is equal to null and set has no, I'm not going to do that. Pair 0. Right is equal to null and set dot has pair 1 right equals I. When we get to the end of this, if left is null and right equals null, sets dot push new set pair. So for example 0, 3, there's nothing in the array of sets already, so these are going to remain null, and so we want to create just a new set in there containing the left and the right, containing the pair. Else if left is equal to null, that means right is not null. What we want to do is sets right dot add pair 0, because the right pair 1 it was in the thing at position right, so we're going to add it. Else if left is if right is equal to null, left isn't, so sets left, we want to add in the thing that we've found. Else both of these things are they're both part of a set, so what we want to do is create a new set, sets.add new set based on the sets left, sets right, but then we want to do sets.splice. Oh, hang on. No, there's a little bit of so I'm jumping straight into this a wee bit. So now we want to remove the old sets that we had. The proper way to do this would be some sort of union find data structure. But I don't want to have to build one of those. So we want to take it from left one sets.splice right one. But this second one here, this left may have completely destroyed the position that we had. If right is less than left, then doing this first splice didn't muck things up. But if right is greater than left, removing the left thing moved everything higher up down by 1. We want to do right minus 1. So altogether, this should give us the sets. Then we want to extract subsequences. This is fairly straightforward. Basically, what we want to do is closed set map indices what is it? We create the array based on the set. We need to sort it. I think that's the way you do that in JavaScript. Again, sorting things in JavaScript is annoying. Actually, you know what? Let's try and do this a bit more long form, just because it's going to get a mess. So it doesn't actually matter what order I extract these things, because I'm going to be sorting the values anyway. Let result is an empty array. Indices.forEach I si its result dot push si. Return result. So for each of the closed sets, what we do is we go through and we pull out each of the characters in the string that was at that index and stick it in the result. So we're going to end up with we're going to end up with an array of characters. And then it's going to be function string sort. Oh, hang on. I think what I can actually do here is for each s, I just want to do, so for each array, sort. I think that works. because here I created an array of characters effectively, and then it's recombine. So the recombine is a bit more complicated. Got the characters and the closed sets. We're going to return a string. What we want to do is just lost my train of thought. So what we know is in each of these sorted subsequences, they are now ordered smallest to largest. So what we want to do is effectively find those closed sets and say, well, in the first yeah. I think we also want to know the length, because then what we can do is let final is equal to new array of a size length, and then we want to return final.join an empty string. Just glue them all together as tightly as we can. So then it is close, is it? So now I've got the closed sets. Hang on. For let I equals 0, I is less than blank I plus plus. The characters in this the C's here are fixed. Now let's do it in closed sets. Let cars equal C's equal card I. So what we want to do is, after sorting the indices, what we want to do is new array based on the indices. I think that's an easy way to do it. And we want to sort them smallest to largest. It's j minus I or I minus j? It might actually be I minus j. I can never remember that because JavaScript sort is just utterly ridiculous. And then what we want to do is indexes for each I, j. We want to do final j is equal to C's j. No, that's not correct. What I want to do is final point is Cj. one-letter variables are starting to hurt me a little bit here. So the logic here is we go through each of the closed sets, we put those closed sets, we put the indices inside that closed set in order because we know the characters are also going to be in order, and then for each position in that one we're trying to fill, we're going to put the next smallest character. And all together, that should fill up the final array, which we can join together. So let's have a go with this. Find closed sets in theory is going to give us 0, 3, 1, 2. Find the subsequences should pull out D, B, and CA. Each of those D, B's, and CA's should be sorted into B, D, and AC. And then when we recombine them together again, what we should do is in the first set, we should see that 0 and 3 are there. 0 and 3 goes to the B and the D. So we sort the 0 and 3, there's 0 and 3. So at position 0, we should put the B. At position 1, we should put the D. At position 3, we should put the D. That looks correct. We do the same thing for 1, 2, and AC. Position 1, we should put A. And position 2, we should put C. That seems to work. Let's give it a quick test, see how many syntax errors I've got. The add does not exist on type any. Line 21. Is it set? Oh, sorry, it's push. Cannot redeclare IDXs. That makes sense. Let's just do it all in one line. Sorted subsequences cannot be found. Oh, that's because we did it in place. Okay. That seems promising. Let's try it with all of the different test cases now. Seems promising. Let's give it a go. Fingers crossed. Are we too inefficient? Doesn't look good. Ah. That's an edge case I hadn't considered. BCAB, 0 swaps. So, if there's something that we can't swap, we need to leave them in place. So what I really want to do is let's have final be the original string that was split up. And then all we want to do is move the ones that we're allowed to move, and this should leave everything that we're not allowed to move in the right place. That's better. Still worried about efficiency though. Ooh, we got one wrong. How did we get that one wrong? Three, 0, 5, 1, 3, 1, 3, 4, 3, 5. So we can do 0, 0, 1, 3, 0, 1, 5, 0, 0, 1, 3, 4, 5. Can all be dealt with. Okay. Let's check whether we actually find that. Should be everything except 2, effectively. Oh. Oh, that's very bad. Find closed sets. Three and 3 can be swapped. Oh, is that the one that's causing trouble? Alright, so if right equals left, do nothing, else let's see if that helps. I think it's that 3, 3 that might have been causing a wee bit of difficulty. That's better. Yeah. Silly. Time limit exceeded. Oh, of course it is. It's this here. This is bad. We need a faster way to create these sets. Okay. What I'm going to do is I'm going to treat this like a graph search function. So we're going to have let result equal the empty array, return result, while true, something like this. We'll break into, yeah. Let's do let edges is just going to be a copy of pairs for now. New let active equals null, while true. If active is equal to null, what we want to do is we want to do let edge equal edges dot pop. Just take something off it. Active equals new set of the edge. Else let edge equal null for I equal 0, I is less than edges dot length I plus well, and edge is equal to null. If active dot has edges 0 or active dot has edges edges I 0 or edges I 1. If the edge we are looking at would extend the set, this is while edges dot length is greater than 0. If the edge we're looking at would extend the set, we want to do active dot add edges I 0, active dot add edges I 1. Add both of those to the current set, and edges dot splice I 1. Remove it from the edges. We don't need to worry about that, do we? And then break. So then that essentially finds an edge and extends the active thing. Oh, actually, no, we did need that. Sorry, edge equals null. So what I'm going to do, take all of those. Edge equal edges I. If edge is equal to null, we'll come back to that, else do that work we just talked about. Except it's not, it's just I, not edges I. So if we got through all of them and found nothing to extend the set, what we want to do is we want to do result.push active is equal to null. And then we want to loop around again. If we've exhausted all the edges, then we're going to stop. Otherwise, we're going to create a new set of active things, building on the next set. So let's see if that works. If I haven't broken anything, egged edge. Wrong answer. Oh. If edges, sorry, active does not equal null, result.push active. Yeah. That's better. We don't now need to be printing information, so let's submit it. It's not looking good. Nope, time limit exceeded. Maybe I can... change how this works a wee bit. Go back to what we were almost going to do there for a bit. In theory, this isn't faster, but it might actually be a tiny bit faster. I minus may change equals true if not may change, then we are done. I don't think I can I test the runtime of this? I don't think I can, actually. I'm not going to bother. Let's just check we haven't broken anything. Basically, it just lets us sweep it in one go rather than having to do some sort of re-sweep a lot. We should, in theory, do fewer passes through it, although could still be doing quite a few passes through it. 64 milliseconds. I feel like that's getting lower. But this could just be because the number is so low, this could just be a random number. There we go. I was worried this is going to be a repeat of yesterday, where we didn't actually finish it in TypeScript. I just re-implemented it in Python and it seemed to work fine. Same algorithm. It was just something about the way I'd implemented in TypeScript was no good. Right, so we have a runtime of almost 10 seconds, which is very slow. Our memory use was entirely with the pack. So we're doing something inefficient here. I don't think it's any of these. These feel hard to improve. It's got to be this. We initially did a very naive union find, and now we've got something a bit more akin to a... God, what even would this be? Some sort of hybrid graph search. Just growing however it can. Yeah, what we were doing before was closer to a breadth first search. This is just a straight up goodness knows what kind of search, but it's fast enough to make it through the test. Whew. Thank you very much for watching. Another doozy. Hopefully tomorrow will be a wee bit easier. Thank you very much for watching, and I will see you tomorrow. Bye. Headaches with